And the application is quite simple, right? So main topic which we are actually applying here is about the lighting and the shading. So the requirements for this lab program is to draw a simple shaded scene consisting of a teapot on a table. Provided you also need to give the suitably the position and properties of the light source along with the properties of the surface of the solid object used in the scene. What do you understand from this? We see that we need one teapot, and teapot should be placed on a table. And the next requirement is, let's just draw a particular table, a rough figure. A table has a tabletop, and a table will have, usually a normal table will have 4 legs. So these are the front 2 legs, and these are the back 2 legs. And he is also letting us know that we have to draw a particular teapot with the lid, right? So this is just a rough image. So we have a lid, let's assume. All right. So apart from that, he is also specifying define suitably with position and properties of light. As we all know that properties of light is I need an object, I need a viewer. So viewer can be over here. Viewer can view the particular teapot from this face, or he can also view it from this particular view also. He can see from this place, he can see from this place, or he can be on the other side. He can visit from this place also. It depends whichever view which you want. So in order to view, a viewer should also have what? Should be positioned over this table. It can be in the x-axis, varying with the x-axis, varying with respect to the y-axis, and varying with respect to z-axis also. The viewer can actually view in a 360 degrees, right? He can view from the top, he can view from the left side, from the bottom, from the right side, from the top. That's how it does, right? That's what it matters. And suitably refers to we have a viewer. Okay. Suitably in the sense this table is not only with a mesh table, or it's not just a filled object. Of course, it's a filled object, but still it should have some properties. So what could be the properties here? The properties could be what will be the table color, right? So what will be the table color? So if it is a table, then it has to be filled with some color, right? So this table has to be filled. In the sense, what I'm telling you is it has to be a valid. It should look like realistic. Of course, computer graphics, we are actually working on the realistic images. How to make it much more realistic is what we look into, right? So this should be filled with a brown color. So now you can assume that it's actually looking like a particular table. And let's assume that, okay, this is one particular teapot which is of black color. Okay, so other requirement or the other required material, or how you want to view it, how you want to see it, that's all depends upon your imagination. All right, so he's not straight away telling you that I have to see from this way or from this way or from the top or from the bottom. It is not specified, right? Always go through the question clearly. So define suitably the position and properties of light. Now we spoke about the light source, right? So light source can be over here. Light source can be over here. It can be on the top. It can be on the bottom. It can be from the side, right? What are the effects of light? Providing the light from different sources is okay, fine, I understand. But what are the properties of light? Properties of light is it has to create a shade, right? So if in case my light source is on top, if the light source is on top, then the shading part, whatever the shading color, it should be on, it should be over on the other side, right? So this is where the all your shading of this particular table to be falling on, right? So here again I have a very light way of here I may have this table, right? I'm just giving the rough image here. So anyhow, this can be a shaded area, right? So this is one realistic, right? Shade. Let's assume this has a light source. Let's make it as a colored one. But anyhow, we are not actually showing this color. I'm just telling you how exactly it sees. And he's also telling us that source along with the properties of the surface of the solid object used in the scenes. Right. Apart from that, for my case here, the program which we have written, the shade will not be on this side. All right, the shade will be on the other side way because I'm viewing as a from the viewer side, right? So viewing from the viewer side in the sense, my light source is over somewhere here, right? That means, uh, yeah, my light source will be from this way, this side, right? So how exactly the light is projected, right? So it is falling from where I'm viewing, right? If your if your light source is the same place at from where you're viewing, then where will the shade will be falling, right? The shade will be falling on the other side. Simple. Right? So let's make it as this color. Right? The shade will be somewhere over here, or it can also be over somewhere over here. It depends on where exactly you're filling it, right? So it depends on the light source, of course. That's one of the property of light. The other thing is, whenever you're speaking about the material in the sense, what type of surface it is. Is it smooth? Is it rough? Is it garroted? Is it having a faceted shape, or it's very curvy, or with the smooth, shiny, right? These are the lighting properties, right? So as we discussed before, much more effects if you want to give with the case here or with our requirement, you can always draw. It can be of one particular uh, one sort of a wall, right? So you can place it over here and you can join it or make it in a sense that it is a wall, right? So that can also be done. But yeah, with my case here, I'm just connecting all the dots so that it gives that effect of the wall. All right. So I think, yeah, this is one wall. Similarly, uh, in this application, I'm also developing another wall, right? Another wall. Um, oops, sorry for this. So it will be in this way, right? It's your wish. You can give however you want with the wall, whichever color you want. That doesn't matter, but still, for our easier understanding here, we're just filling it with, we're just, uh, we are just filling it with the colors, all right? I think this is the rough figure which I can fill. You can also fill it with other color, whichever is necessary. So this is somewhat called as a materialistic property or materialistic view. Or okay, another thing is we also have the light source, as I said, from from the way I'm viewing, right? So even this will also have some shading effects, right? So here somewhere I might get some shading part of this wall, and teapot will be shining, right? Shining in the sense at one particular side it will be shiny, right? Because teapot is a very shiny surface which we will be using. All right. So roughly, this is how teapot will look like. A teapot application will look like. Now we shall look into the code how exactly it looks. Before that, let us see a rough image. Right. So here, if you can see, let me increase the aspect ratio of the image here. And yeah, you can see that I have a table, and table I have a teapot, right? One thing here, I'm not creating a teapot. Create teapot has already been there as an built-in function. I just take that teapot, I fill with whatever colors which I want, and I'll also define the size of a teapot, right? I'm not creating a teapot. Teapot is inbuilt function which is already there. The only thing which I'm worried upon here is this particular side. This side or this particular block has some thickness, has some color, has some texture. All right. So here also I have another box or another wall. It also have the same properties of light. It also have the same property of the texture, right? And what material it is, right? And then we also have a flooring here, right? We also have a flooring, and we have a table with the leg. All right. So now we can see my light source is from the other side, right? So how do I know that light source is over here? Because I get this shininess from towards the position of the light, basically, right? So I send the light source, light properties, and it is making a shininess like effect. All right. So apart from that, yeah, these are the properties. I think we shall look into the code then, without wasting much of our time. As you all know, from where does the application execution start from? Application execution always starts from the main method, and we have to get the vector properties from as an input. So we get the character count and the argument vector array, and we initialize the glut init, right? So with the argument count and argument vector. And what do you see? Is this a three-dimensional image? Uh, is it a three-dimensional image? Yes, it is a three-dimensional image. You can easily say that the image is having some three-dimensional properties, right? So three-dimensional properties, what all come under the three-dimensional properties? There will be a depth, there will be a buffering, right? So what is the depth here? Do I look into any of the properties of depth? That means this is near and this board is farther, or this board is farther and this teapot is near. Of course, teapot is near and this object of a wall is on the back end side, right? So that is one property. And the other thing is, are we using colors here? Yes, I'm using colors with the values of red, green, and blue. And do we have any rotation or any animation here? So is there any necessity to have more than one buffering? So no animation, no rotation, and nothing much involved in the animation too. So single buffer is more than enough. And if you have any rotation, if you want to rotate any object, if you want to spin something, if you want to turn, if you want to view anything, you need a double buffer. So the usage of single buffer is more than enough at this particular point. The other thing is, as you all know, this facility of glut init window size, it's 500 by 500 pixels, and the position is 0, 0. That means it starts from this particular location, and the name of this particular window is teapot on a table. So is a teapot on the table is what the application which this window is holding. And yeah, we go with the init. As you all know, init method has clearing with respect to the background. What's our background? 0, 0, 0 refers to black color. That means my background is black. And we are using, we are drawing something. We have a table, we have a teapot, we have the wall, which are including with respect to some lines and projections. So we are letting know that yes, we are using matrix mode with GL projections. That means we are drawing something. So initializing, whenever you use a projection mode, then automatically it will be with the, you have to load the matrix, and we don't load it with random values. We initialize with the identity matrix, right? So the diagonal will be, the values will be there, as it is a 3-dimension too, x coordinates, y coordinates, and as well as with the z coordinates also. Make an impact over here. And we also have GL ortho function, that is your which is giving you the 6 values, right, with x and with the values of x and y. And yeah, we have the GL matrix mode with the GL model view, positioning where exactly it has to be set. We will be letting it know. And apart from that, straight away we go with our logic of our application, that is our display. Right? We go for the display method. And what is that? You need to get it. Right? Display method is where the logic holds. So initialize the thing which are needed. So what are the things which we have over here? What are the things which we have over here? Initially we have a teapot, right? So we have a teapot, and we have the tabletop, and we have this table leg, and we have the wall. These are the 4 important objects which we are actually looking into, and these 4 objects are given with values, right? So it will be with respect to the thickness, or how do we use it, right? So there are some thickness of the wall here, there is some thickness of the table. If it's a with the leg, it has some changes. So apart from that, we also, as we are using a single buffer here, it's your thing to be clearing the buffer bit as well as with the depth bit. So both the things are needed. So you need to clear the buffer bit. Why? Because you use a single buffer, and previously whatever we had in that buffer, we need to take it off. If you're not using it, you get some other colors, right? And the depth buffer too, you have to clear it. So we use that line, and dealing with the glue load identity. And yeah, load identity is where we are using the matrix methods for most of our calculations here. So load it with the identity whenever you create it, whenever you add any of the when you want to create a leg, or when you want to create a top of a table, or on the side wall, or on the basement, right? So all these things have to be taken into consideration. We also have a method called as glue lookat, and it has the 9 varieties of I, where it is look and at, right? So I with X, Y, and Z, and look is 0, 0, 0, and what you are viewing, right? So these are the attribute values which glue lookat will be actually holding, and it's basically the property of your camera and viewing. So from where you're viewing, what you're viewing, right? So I'm viewing from this way. That means my object should be here. Right? What are you looking? From where you are looking. Right? The object might be here itself. You might be viewing from X. We can vary the X and Y, and as well as with the Z directions of the camera position. But the other thing is, okay, you can vary this, provided the object should also be somewhere else, right? So it should be from here. Right? You can view from here, right? You can project it somewhere, but the I look at all the 3 values are actually giving some values over here too. The other thing is, here I have differentiated the method of light. Right? Light has different properties, and these properties are different for a different material. Right? So here we can see with the lighting arrangements, which I can call, and we have the ambience with the ambience color of it, and we have the diffuse as 0.5, and the specularity as 1, and the shininess for as 50. And we also know that more the shininess coefficient, if you give it as with the 100, right, that alpha value which we actually looked into, right? So that alpha value, if it is more than 50 or 100, then you have a very shininess, right? And you also can see that the shininess is applied only for the teapot, but not over everything. Right? We will see it regarding the light effects for which all we are actually providing it, right? So we have this these are like the built-in things which we actually use, right? So for ambience, materialistic property is you have it from the front view, and GL ambient is what the built-in parameter says, and what are the values for your ambient is what we have given here, that is 111. So ambience of the color will be taken. Similarly, for ambience, diffuse, and specular, as well as with the shininess coefficient, you have to initialize with the values. So any there won't be any changes over here, right? If you can change with the values, only these are the values which you can change. And provided whatever the array, whichever you have given here for the ambience value and for the diffusion, for the specular, as well as with the shininess, you have to provide it clearly over here with the same name. All right. So where exactly is the lighting position? The lighting position is 2, 6, and 3. 2 with the x-axis, 6 with the y, and 3 is with respect to the z-axis. So light intensity is we have varies from 0 to 1 actually. We have given it as 0.7, 0.7, and 0.7 with respect to the intensity of red, intensity of green, and intensity of blue. Right. So next is we have GL Light 0, which is giving us the facility of the lighting effects, and proposing that how it looks like, right? We also have the position of the light intensity which we have specified over here. We give it over as an array towards our function GL Light FV, and similarly for our intensity, that will be our diffused light that will be sent with the array name, whatever you have specified over here. All right, so that's about the light properties. So once we are done, we need this is what adding the light properties. We have done it. So first thing is we are creating a teapot. Right, create a teapot with the size of 0, and it's a filled teapot. Right, so filled teapot, and apart from that, you're also creating a table stop. Right, so with respect to the few values, here I have the properties of it, properties of each and everything, because as I told you, I need a teapot, I need a tabletop. There are 4 legs for the table. Remember, 4 legs. Any one of the leg you skip, it will be taken off. As simple as that. And also you need to be very specific in letting the people know in the diagram where exactly the leg should come. Leg can come anywhere, right? Leg should have the small thickness too. Right, so it also have those values. And how many walls do we have in the image? We have 1, 2, and also the basement. Remember that we have 3 walls, right? One is on the front, on the side, and as well as with the bottom. So we are creating 3 walls here by giving the wall specifications of 0, 0 and some values of it, right? So first we'll start with the teapot value here. So uh, 1 second. Okay. So teapot is what we are creating now. Yeah, going back to the teapot method. Okay, what does that do? It is taking 3 values. One is with 0, and the other one is for some value of teapot P, and the other one was with respect to the Z. Right. So what are these values X, Y, and Z? And here those X and Y are actually in which you are facing it. Where exactly you are facing it? What are the X cases? Right? So those are the X, Y, and Z value. You can move it, varying this X, Y, Z values. You can move on the table if you want. You can also put this T table on the top, on the floor, right? So you can place it over anywhere. It's artificially generated image. You can put it anywhere. on this particular screen. All right. So, and what type of a teapot it is? It's a solid teapot. You also get a mesh teapot. You also get a faceted teapot, right? So it is a very simple, a small teapot. Varying with this value will vary your teapot size. Varying, I have given it as a 0.1. If you give it as a 1, it will be 10 times the bigger as that of this teapot, and it will be taking complete place of this table and doesn't look good, right? It should be considerably matching with respect to the environment with which it is best suited. So point one is the size of your teapot, and yeah, it's pushed into the stack, right? Why are we looking on the stack here? Should be your concern. Uh, we are stacking everything one after the other, right? So whenever I say stacking here, uh, this is first, this is second, this is third, and this is fourth. Everything is placed one top of the other, right? So whenever you take it off, if you take this teapot outside, then you get a table. If you take out this table top outside, then you get the uh, chairs of it, right? Then if you take out the chairs, then you get the wall. That's what exactly this push matrix, pop matrix is actually doing. Everywhere on the tabletop, for the legs and for the walls, we are using the stack or and push methods to deal with it. I hope we don't have any issues regarding the teapot which we have created here, right? So next, once we are done with the teapot, we have created the teapot, then we come back. Then we come back with respect to the display mode, right? So what is that we are displaying next? The teapot is done, the tabletop is the next one. So we have to create the tabletop. It's if you place this teapot on the other side of the wall, you won't be seeing the teapot itself. Why? Because in the stack, last come first in, right? Right. So last come first out. Last in first out. So the next thing is once you have the teapot, then you are facing the table. If you mess up with the leg and table, leg will be seen and table will be on the other side. It's just with respect to who has drawn when, as simple as that. All right. So once the teapot is done, then we are moving with the tabletop. Tabletop value is 0, tabletop P and 0. And also remember that we are also sending the XYZ values. XYZ values for teapot, that was 0 with X, and teapot is over position is 0.07 with negative Y. Remember that. All right. So next, tabletop is 0, and what is the tabletop value here? That is negative 0.15 will be with the y-axis and with the 0. So this function will be called the tabletop. Okay, tabletop is over here. The same way, right? We have a push matrix, we have a translate, and here we are scaling it to what box we are looking at, right? Of course, here also I'm not drawing with respect to the lines, right? As you can see, I'm creating a solid structure because the solid cube is already a built-in function. So what my suggestion to you is you should know which are the inbuilt functions which are already available. We have many of such things. We have a donut-like image. We have the filled objects, faceted, line, and rough surface, shiny surface. Many things are already present. You just need to call it, right? You just need to call it and override with your values, right? So once you override with the values, whatever values which you gave, it will be taking into consideration. So yes, we are using the glut solid cube of with the value of 1, and we are scaling it with the x, y, and z, and we are drawing it as simple as that. So what do we have? We have the teapot. Behind the teapot, we have the tabletop, right? So we have a teapot, and behind that we have a tabletop, and behind that we have 4 leg values, right? 4 leg values. So leg P is giving you 0.15. Remember that. So these are actually dealing with respect to the y values, and if you vary with any of these values, those images will change when we'll look into that, right? So creating the first leg, we'll look into the one of the leg. So one leg is again, it's a solid cube. and it is scaled in x-axis of 0.02 and y with 0.3 and z with 0.02, and we have a beautiful leg which is created, right? So similarly, leg 1, leg 2, leg 3, leg 4, and all the 4 legs will be in turn created. Then apart from that, we need 3 walls, one with the straight, one with the right, and one with respect to the third wall. One is with left, one is with right, and the other one is on the bottom, right? So we look it over in the wall, same way with matrix, translate, here also scaling, let solid cube, pop matrix. Right? It's a very simple application. Only thing which you need to look into here is values, right? If you give random values also, it will be something else, right? So it should be a proportional value, which I can say, right? So once you create all these value, then we will be calling it, and it will be printing. And here we also need to let know that in the function we have utilized the lighting properties, the light properties, the light source, what type of surface it is, the normalization, and what type of 3D depth which it is giving. And I'm putting it in a loop. Why? Because it is not like just it is showing and it is turning it off. All right, so let's run. Let's anyhow running in the sense I have already run the application. So we here we have the teapot, we have the table, we have the 4 legs, and we have all the things, right? So we'll just vary the values of few things here, and let us know. The first thing is let's vary with respect to the teapot size. So I'm just giving it as a 0.5, and whenever you look into the particular teapot here, it will be a very big one, considerably to that of the previous one, right? So uh, 0.1, if you also need it very small, give it in the decimal places, and if you give 1 also, it will be a very huge one, a very huge teapot. Can you see this? Everything it has basically it has overrided, right? So it is a very, very, very big teapot. So make it, keep it as simple as it looks, and also yeah, let me make it as 0.5, so it will be considerably a much more smaller teapot, right? So um, it's all with your hands or the programmer, right? That's what I can say. And varying with respect to the tabletop, right? Scaling with x, y, and z, right? So these values, right? So if I give everything as 0.5, so if I have a 0.5, 0.5, 0.5 everywhere, as you can see, it will give you as this particular box, right? With x value how much I scale, y value how much I scale, and with z value how much I scale. So these x and y. So it became a cube, in fact, right? So why? Why? Because I have given the cube values here, right? So try to give the valid values. So in x it is elongating it for the 0.6 times, and for the y it is elongating for 0.02. If you want it to be like much more bigger than that of what it was looking, and you can actually see that it's a bit thicker with respect to the size, right? But still it's a table. I'm not telling that it is not a table, but it has to match with the aspect ratio which we are looking into, right? So with the 2 value, and again you can always increase the size, right? I can increase with respect to the solid or mesh or whatever the case, right? The next one is the table leg with x, y, as well as with the z, right? As you can see, the thickness of the table leg here is 0.02. The thickness of the table with x is 0.02, but y is more. Y is more. And how much is that y? Y is 0.3. And what about the x value? X thickness is 0.02. What about the z? Z is also a very small one, right? So if you want it to be a very smaller leg, if If you want it to be a very smaller, like, then I'll give it as 0.5. Right? So dealing or giving any values of that will reduce your leg to very small size. Getting? So these are the variations. We don't have much things. It looks like okay, something new which we are learning, but it's a very small and straightaway image. All right. So yeah, here you can give it as 0.2 or 0.3 or whatever the value. Um, so similarly, all the four legs will be created based on the XYZ, whichever you send it over that. Those XYZ are different for different legs. Different for different legs. Always also deal with the proper values, right? If you're dealing with irregular values, gone. It will print you something else that we don't want. And also with respect to the wall here, we have three walls. Basically, these walls are also a solid cube, right? So the same method, as I said, everything will be the same with whatever the XYZ values. That is what you have to remember, right? And also we are rotating the wall for some wall and some for other wall we are not rotating. So rotation of wall is how exactly you actually view it over here, right? So the wall is actually placed in the 90 degrees to each other, like orthographic, right? Like orthogonal to each other. So that's one particular case which you have to look into. So I think you people have enjoyed. So yeah, thank you. That's it for this Teapot session.